All right, folks, I'm going to do a problem here. This is from the Chapter 5 quiz. This is problem number 31. This is at the request of one of you folks. Okay, so here's the problem, and I'm going to do it a little bit differently this time. Instead of having the book here, looking at the book, I'm going to just direct you to where to look in the book and have you do it that way, if you don't mind. Okay, so the problem is as follows. There's a youth group. It has 8 boys, 6 girls. If a slate, in other words, a group or a subset, if a set or a slate of 4 officers is selected, find the probability of the exact results below. Now, they don't use this terminology, the exact results. The reason I wrote it that way is because I want to make it abundantly clear that that's what the problem is all about, is to find out what's the probability of getting a particular exact result. Okay, so we're going to see here in just a minute what are the various scenarios that they want you to talk about. And again, look in the book, you'll see what the exact question is. But I want to have a discussion first, okay? I think it's very important, and I strongly urge you to do this yourself. You should always have a little bit of a discussion on these problems so that you can kind of explain it to yourself and truly understand what's going on. Okay, so the first thing I said here to myself was, see the formula for the hypergeometric distribution that's on page 294. Okay, there's a formula there. We don't really need that formula, to be honest with you. It's something that he has in there and he talks about, but we don't need that formula for this problem. This problem can be solved just by common sense and intuition. Example 5-32, example 5-33 kind of are similar to this, so you might want to take a look at those. But you also can look back in chapter 4, example 4-50 is a discussion of this sort of problem, but he doesn't use the term hypergeometric distribution. This problem is described or explained in section 4-5, this kind of a problem, okay? All right, so what's going on here, really? I mean, if you really think about it just for a second, we're picking these kids, right? Let's go back up here. We've got the 8 boys and 6 girls, so there's a total of 14 kids. We're going to pick 4 officers, okay? And we want to know what's the probability of getting a certain outcome. So let's just go down here and look at one of them anyway. This will make you dizzy. Okay, so here is one of the problems. Problem A, the probability that exactly 3 are girls. So if 3 are girls, then that means that 1's a boy, right? And then another problem B, I think, was 2 girls and 2 boys. All right, so we're always trying to find some probability of some sort of a particular outcome, some sort of a particular slate or subset. Okay, so when we pick these kids, let's say we pick 3 girls and 1 boy. Well, you're doing 2 things, right? First, you're picking 3 girls, and then you're picking 1 boy. On the other problem B, I think it is, you're picking 2 girls and you're picking 2 boys. Well, that's like flipping a coin or any other probability experiment. You do them one after another. What do? You multiply the probabilities, right? Well, multiplication is commutative. That means that it doesn't matter what order you do this in. So this problem is actually very similar to in chapter 4 quiz, problem number 38 that I did, and I put on. I did a video and I put it on Canvas and on YouTube. That problem was, how many ways can we select 5 sopranos and 4 altos from 7 sopranos and 9 altos? So can you see that it's really the same problem? Instead of picking sopranos and altos, we're picking boys and we're picking girls. Okay, so it's the same exact kind of a problem. So if you need more help with this, look at that problem, chapter 4, number 38. Okay, so back to the discussion here. I'm in this section here that I call discussion, all right? So first of all, I said, look at the formula. Then I said, look at this example. Verbally, I just told you another example you can look at. And then now here's some more discussion here, something that I pay attention to as I'm doing the problem. I say, okay, we're going to pick these officers without replacement. The order doesn't count. The arrangement doesn't count. It doesn't say anything about picking a president, a vice president, and so forth. It just says pick the officers. So if the order or the arrangement does not count, we don't care about that. what do we use? Do we use combination type counting or do we use permutation type counting? Well, I hope you know by now that we're going to use the combination type counting. If the order doesn't count, we use combination type counting rules. So here's the formula. N choose R. Here's the formula. N factorial over this. Okay. Now, I think I've mentioned this in my videos before. The way I always look at this is you can multiply all this out, of course, but really what's going on here is it's when you write out the formula, it's going to be the n factorial is going to be n times n minus 1 times n minus 2 times n minus 3 and so forth. Well, how many of those terms are going to survive? Well, r of those terms are going to survive. The rest of them are going to get canceled out. And then we're going to have the r factorial here. And we'll see that here in just a minute, okay? But keep that in mind. That's the kind of the shortcut way of writing this out. All right, so problem A is the probability that exactly 3 are girls. So here's my solution. There are 8 boys, 6 girls, so the total of 14 kids. Therefore there are 14 choose 4 ways to pick 4 kids out of the 14. So that's going to be your sample space at the bottom of in the denominator, okay? There's 14 choose 4 ways to pick 4 kids out of the 14. So using our formula, it's, n, here's my n, this is my r. So it's n factorial, that's 14 times 13 times 12, blah, blah, blah. And then here it's 14 take away 4 factorial times 4 factorial. Well, 14 take away 4 is 10 factorial. Okay, so what's going on here is that it's 14 factorial is where am I here? 14 times 13 times 12 times 11 times 10 times 9 times 8 and so forth. So from here all the way to the end, that's 10 factorial. So that's going to cancel, right? So the 10 factorial cancels out with the 10 times 9 times 8 times 7 and so forth over here. So what it really boils down to is the first 4 guys up here, the first R guys up here are going to survive. So it's 14 times 3 times 12 times 11. That's the first 4 guys. 1, 2, 3, 4. So that's how I always think about it. And that way I don't have to remember these stupid formulas. I mean, it makes me crazy trying to remember these formulas. So it's the first R guys on top, and then it's R factorial. So multiplying this out with your handy-dandy calculator, you get 24,024 on top and 24 on the bottom. So that's 1,001 in the denominator. So that's the number of ways that something can happen in the sample space. Okay, now, how many ways can you get exactly 3 girls? How many ways can you do that? And similarly, how many ways can you get exactly 1 boy out of the 4? We're going to figure out both of those. We want a total of 4 kids, so we choose 3 girls and we choose 1 boy. How many ways can we do this? Well, the total number of ways of doing this is going to be the number of ways to pick 3 girls times the number of ways to pick 1 boy. Well, here it is. It's 6 girls, choose 3 of them. 8 boys, choose 1 of them. Okay? Boom, there it is. There's the formulas. Just using that same formula that we started with. So crank this sucker out and you get 160. Okay? So the probability is going to be the probability of exactly 3 girls is the number of ways of getting three girls and 1 boy. That's on top. That's the numerator. That's the total number of ways of getting what you're interested in. And then on the bottom is the total number of ways to pick 4 kids out of the 14. Where does this come from? This is just the basic rule, the basic definition of probability that we define on page 189 in section 4-1. The probability of some event, and here's the event is getting exactly 3 girls and 1 boy. That's the number of outcomes in that event, okay, that E, over the total numbers of outcomes in the sample space. So I direct your attention to page 189 in section 4-1. Gives you this formula here and a couple of examples, I believe. Okay, so the probability of exactly 3 girls is the number of ways of getting 3 girls and 1 boy over the number of ways of getting 4 kids out of the 18. I just figured out the top part a moment ago. That was the 160, right? That's the That's the number of ways to get 3 girls and 1 boy. Multiply that out, you get 160. So on top, in the numerator, is 160. The denominator is 1001. Do the division, you get 0.159, blah, blah, blah. That's approximately 0.160, and that's the correct answer. Okay, so now let's say the young lady that asked me this question, I think her problem was one of the things that she was saying, I think, was that she wasn't getting the exactly this. Well, probably what was happening is, I'm kind of guessing, is that she was dividing by 1,000 maybe instead of 1,001. I don't know. She didn't send me her work. So that's the sort of thing you kind of have to, when you ask me a question, if you send me your work, I'll look at it and I'll try to figure out what you're doing wrong. Okay, so let's take a look at B, question B. 2 girls, that's the same idea. 2 girls, 2 boys. Number of ways of getting 2 girls and 2 boys is, this is the number of girls, 6 choose 2. This is the number of boys, 8 choose 2. Crank it out, crank it out. Now, obviously, when we're doing this, you should pause this video, write down this stuff, do the calculations yourself, make sure you know how to do these calculations, okay? This is a template for you, but I'm not doing every single step for you. You've got to do that yourself. Okay, so the final count here is at 420. There's 420 ways to get 2 girls and 2 boys. Okay, so the probability of 2 girls and 2 boys, it's the number of ways of getting the 2 girls and 2 boys. That's the number of ways of getting the event that we're looking for, and that's in the numerator. The denominator is the number of ways of picking the 4 kids out of the 14. That's my sample space that I've been, talking about. So that's 420 over 1001. Crank it out, and boom, it's 0.4195804. That rounds off to 0.42, and that's the answer the book has. Okay, finally, C, all 4 are boys. So that's 0 girls, 4 boys. Okay, 6 choose 0. Whenever you have, n choose 0, it's always going to be equal to 1, right? You multiply that out, you'll see exactly what I'm talking about. It's, all you need to know is that 0 factorial is equal to 1, and that's all in the book. So hopefully this is all familiar to you. Okay, so 6 choose 0 is 1. 8 choose 4 is right here. That's the, same thing as I've done so many times. The first 4 guys of this 8 factorial. So 8, 7, 6, 5, and then it's 4 factorial on the bottom, 4, 3, 2, 1. Crank it out, and you get 1680 over 24 for this guy becomes this, and that becomes 70 over 1001. That's 0.0693, and that gives me approximately 0.07. And there's a big smiley face, big happy face, because I got the exact same answer that the book has. Okay, so the exact answer is important, of course. I mean, if you have a job, you want to have a good answer, right? But on the other hand, the most important thing for this part of your life is to understand these steps. So I'm strongly advising you, do it the way I do it. Write down the discussion, write down the formulas, explain why you're doing things, and it will, in the long run, it will save you time because you'll understand the material so much better. So that's my advice. Follow my template that I give you here so that you can make sure that you truly understand it, and write it in a nice, clear, expository way. I'll let you look that up. EXPOSITORY. Expository. A nice expository way. If you got a 15-year-old brother or sister, pretend that you're explaining it to them. Okay, that's the best way to learn this material. Okay, that's the end of this video. I certainly hope that this helps you.